Hey y'all, today's objective is inequalities and graphs. You may remember inequalities from 6th grade, so this should be a quick review. An inequality is less than, greater than, less than or equal to, this little line under could mean equal to, greater than or equal to. So these are the 4 inequalities that we're going to be dealing with. And then to graph, you're going to graph on a number line. So on every time we graph, you're going to have a number line with 3 numbers. And then you're going to graph with an open circle. If it's less than or greater than, if it's one of these two, less than or greater than, it's going to be an open circle. If it's equal to, less than or equal to, greater than or equal to, it's going to be a closed circle. So those are the 2 things to remember. Open circle or closed circle on a number line. And then there's some shading. All right, so how to graph. First, let me show you how to graph. Example 1, y is less than 3. Y is less than 3. That means whatever y is, it has to be less than 3. Because it's not equal to, we have an open circle. Notice an open circle on 3. Since this is our solution, 3, that goes in the middle. And you always want to have 3 numbers on the number line. So on a number line, 2, 3, and 4. It's an open circle because it's less than. Then we need to shade. So let's talk about the variable. The variable is less than 3. Y is less than. It's next to the point, which means smaller. And if the variable is next to the point, we're going to shade smaller, so we're going to shade left. So we just shade a number line to the left. And that's an example of graphing. Here's example 2. A is greater than or equal to -2. So let's talk about this -2 that goes in the middle. And then we have our number -3, -2, -1. Because we're negatives, they're going in the opposite direction. It's a closed circle this time because of our equal to. If it has that equal to, that means it's going to be a closed circle. And now we have to figure out which way to shade. A is greater than or equal to -2. A is next to the mouth, so that means A is greater. So we need to shade towards the bigger numbers, which is going to be to the right, towards the positive numbers. The right is always bigger, the left is always smaller. All right. A little more graphing. Example 3, -6 is less than g. This time the variable isn't first, like in those other examples I showed you. So let me show you what to do if the variable is not first. -6 is less than g. Again, we start with -6 in the middle, and then -7 and -5. So -6 goes in the middle. We want an open circle because it doesn't have the equal to, so we want an open circle. And then let's look at where our variable is. Our variable is right here. Is our variable next to the open mouth, or is it next to the point? It's next to the open mouth, which means, so it's open to the mouth, which means bigger. So we're going to shade to the right, to the bigger numbers. If your variable is next to the open mouth, which means bigger, then you're going to shade to the bigger numbers. Example 4, 2 is greater than or equal to c. 2 is greater than or equal to c. Because it's 2, 2 goes in the middle, and then you have 1 and 3, so 1, 2, and 3. Since it has this equal to, that means it's going to be a closed circle. And let's look at the variable. Is the variable c next to the open mouth, or is it next to the point? It's next to the point. So that means we shade smaller, and that is to the left because the left is always in the smaller direction. So here are 2 examples when the variable isn't first. All right, so I want you to try. I've given you 2 examples, and I want you to graph them using the number line and write the problems down, pause the video, and then restart the video when you're ready for me to explain it to you. A is greater than -5. 10 is greater than or equal to f. Okay, -5 goes in our middle. And then we have -6 and -4. It does not have an equal to, so that means it's open. and the variable is next to the mouth, so that means big, and we're going to shade towards the bigger numbers to the right. That's how you would do number 5. Number 6, 10 goes in the middle, so we have 9 and we have 11. It does have an equal to, so that means it's shaded in, and the variable is next to the point, which means smaller, so we shade to the left to the smaller problems, the smaller numbers. I hope that you got those correct. You can also use inequalities to model real world situations, because you know we always do real world situations, and you can use inequalities. So I've got 2 examples to go over with you. Do you like my little car? So if you're driving down the street and the speed limit is 55 miles per hour, let's talk about how that looks as an inequality. First thing you do is you need to pick a variable. You can pick any variable. You can pick an S, you can pick L. I'm just going to pick X because it's just easy to use X. So I'm going to pick a variable X. Second thing is you look for keywords. So in this, there's not really any keywords except for the fact that we're talking about a speed limit. And the third thing you need to do is you need to use logic. You need to use your logical thinking skills. What does it mean if the speed limit is 55 miles per hour? How fast can you drive? Well, I know I can drive 55 miles per hour, and if the speed limit is 55 miles per hour, how are you supposed to drive? Are you supposed to drive 60, 65, 70? Or are you supposed to drive 55, 50, 45? And your parents might say, it's okay if you go 5 miles over, but the speed limit, really, that is the maximum that you were supposed to drive. So the speed limit means we can go 55 miles per hour or we can go under. If you go over, then you might get a ticket. So how would we represent 55 miles or lower? Well, can we go 55 miles per hour? Yes, so we know it means equal to. So do we want our speed, X is our speed, do we want to go above 55 or below 55? And we want to try to stay below 55, so that would be X is less than or equal to 55. A speed limit is going to be less than or equal to when talking about approaching the speed limit. Now example 8, these are people squeezing into an elevator. And have you ever been on a crowded elevator? It's a little awkward. So here are a bunch of people squeezing on an elevator, and the elevator says no more than 20 people. No more than 20 people. So first we want to pick a variable. Again, I'm just going to pick X, and I know that it's going to be 20 people. Let's look for keywords. No more than. No more than is a huge keyword. So what does that mean, no more than? If you're in an elevator, can 20 people fit in? If it says no more than 20 people. Yes, 20 people can fit in, so we know this means equal to. So which way does it go? 19 people or 21? If there's an elevator that says no more than 20 people, then can you fit 21 in there, or should you go back to 19? And I hope you said go back to 19, because no more than 20 people means 20 people or less. So X is less than or equal to 20. No more than means that is the most that you could fit into the elevator. So less than or equal to 20. All right. I want you to try a couple real world situations. Write an inequality to model the real world situation. The first one, it says you must be at least 50 inches tall. You know, when you go to the fair, there's always height limits. You have to be a certain height. So in this problem, you must be at least 50 inches tall. And in problem 10, you must score more than 10 points to beat the record. So let's say you're a basketball player and you are close for the most points in a game. Then you have to score, you must score more than 10 points to beat the record. So I want you to try these. Pause the video, and then when you're ready to hear the explanation, you can restart the video. So first I'm going to go over number 9. You must be at least 50 inches tall. Remember to pick a variable. So I'm going to pick X. And then I know it's going to be 50. So let's look for keywords. At least. Keywords. At least. What does that mean? I know it has the word least in there. So does it mean you have to be less than 50? Or does at least mean you have to be more than 50? That's what we're trying to decide. And the last one is use logic. So let's think about it. If you go up to a ride at the fair and there's a little ruler and it says you must be at least 50 inches tall. If you come and you're 45 inches tall, can you ride that? No. What if you're 55 inches tall? Yes. What if you're exactly 50? If it says you must be at least 50 inches tall and you are exactly 50, do you get to ride it? Yes, because at least means 50 or more. So even though it has the word least in there, don't let it trick you. At least means it could be 50 or more. So this is the correct answer. X is greater than or equal to 50. Number 10, let's pick a variable. You could do P for points. It doesn't matter. I'm just going to use X. And we know that it's 10. So now let's look for keywords. More than. That one's pretty straightforward. More than. Let's use some logic. You're trying to beat the record. How many points do you need to score? More than 10. Right? More than 10. Now, if you score 10, will you still beat the record? No, because you need more than 10. So this one is not equal to. It is just X is greater than 10. So there are some real-world examples of how to use inequalities. And have a good day.